What's in the box?
Hey, it's Eamon with ipXchange. We've got a new product from Ignion, right from Embedded World. And to celebrate this, we recorded an ipXperience with Jaap Groot a couple of weeks back, and that was before this product had a name. Now it does. Oxion. Hey, it's Eamon with ipXchange at the ipXchange studios. I'm here with Jaap Groot from Ignion, and they've got a very interesting technology. We've talked to some of their team at Hardware Pioneers Max before, but we wanted to get the scoop straight from the head of the source. So, Jaap, I do have a sample of one of your antennas here that I picked up earlier last year, but can you tell our audience what is a virtual antenna and how does this differ from the normal antenna technology that people usually encounter?
Sure, Eamon. Well, first, thanks for having me. And yes, you did a very good laydown of the technology already with Mark last year. So I recommend people to look that back if they want to understand more of the details. But let me explain to you why virtual antenna technology is so special. The fact of the matter is the people who invented this have invented technology, antenna technology for a long time. And actually you and the rest of the world, you hold it in your hand because the people who did that red part that you showed are also in the mobile phone. And we covered over 90% of that. So that's some heritage. The way we think, or at least I think about antennas is like a tire to a car, meaning that people buy cars, but they don't worry too much about tires. And sometimes that's wrong. You can ask the Ferrari guys why they don't win the Grand Prix, but if you don't have the right tires, you're not going to win the race, even if the driver might be brilliant. So virtual antenna technology overcomes this tire problem basically because it's not an antenna, it's a booster. If you look up the IEEE documentation, right, it's not radiating. And as a result, that's why we call it a virtual antenna. It's not an antenna. That's the whole reason behind it.
Oh, interesting. So I'm assuming that you still have antenna in the name because it is helping with connectivity. But how does do you use it in the same situations as antennas? And if so, what's the difference in how you integrate it when compared to a normal antenna?
Yeah. So the main characteristics of a booster, and that's what it really is that think about it like a drumstick on a drum. So if you take that antenna and you hit the drum, the sound depends on the drum, not on the antenna, or not on the stick, right? So at the end of the day, we use the ground plane, and so do some other products. But we only use the ground plane. There's no intrinsic frequency defined in the part. Even if it works well in certain areas or better in certain areas, that's more due to the size. But other than that, this is an omni-fitting tire for any car. And the reason why we are the only ones that have it is because we've protected it very well with patents and IP.
Okay. So from that, I gather the ground plane of the product is acting as the antenna, correct? Is that correct?
Correct.
And then this tunes that ground plane to act at the frequency that and boosts at the frequency that you require for your communications. Is that right?
Correct.
Okay. So what are the limitations to this technology in terms of what frequencies you can tune to? And is this, I would assume this is highly dependent on the size of the product itself, if it's related to the ground plane.
Yes. So first of all, the products, I have the samples here, but everybody can go to the website, right? The smallest ones are even, almost invisible. They're very small. The size of the product kind of defines, where it shines in terms of in the frequency domain. So the smallest ones do very well in 2.4, so Wi-Fi and Bluetooth. If you need a bit more wideband, more frequencies, like in cellular or ultra wideband, you typically end up with a bigger part. But all these parts work from 450 megahertz up to 10.6 gigahertz. That's our domain.
Okay.
which covers almost anything. But for example, what we don't do is millimeter wave in 5G.
Okay.
Our products
Fair enough.
do not cover that. And as you said, there's a few problems in the industry, but one of them is there's chip antennas all over the place. The tuning is the issue, not the chip antenna itself. How do you make this to work? And I think that's where most customer journeys kind of get stuck in terms of understanding how the part behaves on a different PCB with a different frequency, with a battery close to it, etc., etc.
Okay. So in terms of the perfect kind of product that you'd use this type of antenna solution for, or virtual antenna solution for, where do you see Ignion's antennas being used for the most part?
So our current market experience shows several areas of unique competitive and sustainable advantages. You got to keep in mind we do about 5,000 designs this year. So
Okay.
that's 5,000 products with customers, some one, some multiple. So let me summarize in which use cases we see the most traction, because most likely
Okay.
that's because we do well, right? So the smaller the device, the more the size of the antenna and the clearance are critical. If you think about, this is an example from Nordic, it's 50 by 50.
Oh,
50
one
by
of the
50.
thingies.
Yeah. So
Nice.
this is challenging. This is small, and there is on the back there's a battery. There's all kind of things that do not do not help the antenna.
Yes.
So what and this is a cellular device, right? Typically, we see when things get smaller. Think about headsets or earbuds or stuff like that. Yours are wired. A lot of people use wireless stuff, and then space becomes an issue. And that's where the size of the part comes back in, right? Your part needs to be small enough to fit in an earbud. So the second element where let's say the technology shines is when you have multiple antennas on board. Think about the tracking device on a container which is connected through cellular, let's say, but you also have GPS. That's another radio. And most likely you also have BLE for provisioning, so to initially install the device. And typically, the radio world advances. Like 2 weeks ago on Mobile World Congress, the hype was NTN, non-terrestrial networks. Nice. So now we have coverage everywhere, right? And Elon Musk and his satellites can see whatever happens everywhere in the world. But in my world, this means another frequency band, another radio, enhanced complexity. And the more complex the solutions are, the more our technology starts to shine. That is, let's say, a conclusion. So in trackers, this is a good example. And then the last, let's say, market or typical thing is when companies are big and have a one SKU approach. They want one product that can be covering the whole world. So let's take a metering company. I'm not going to give any names, but we serve, I think, 7 or 8 out of the top 10 worldwide. They want to build once the product and be able to deploy it in Brazil, in China, and in Hungary. And those radio frequencies in those countries change. So with our virtual antenna product, you can tune it to the likings of all these radio environments without changing anything to your design. And that's extremely powerful for these companies.
Okay, so that leads into quite an interesting question. So from that, I'm sensing that the key advantages of Ignion's solution is if you've got multiple signal bands that you need to be using, then do you use a single Ignion booster virtual antenna for the multiple frequency bands?
So the most complex product can deal with 3 radios at the same time.
Okay.
The one that I was
in the most complex of the virtual antennas.
Yeah. Well, this is the product is called a trio, but at the end it has 3 IOs, so you can deal with 3 radios. And this is just because there's not space. There's no space. Otherwise, people would put 2 or 3. Is that unique? I don't know. I think there are many chip antennas, and they're all good products. The uniqueness sits in the fact that we can tune it more easily and potentially better than anybody else.
Cool. So how does one tune one of these antennas?
Yeah. So I mentioned problems in the industry. I want to go back one problem earlier.
Okay, yeah.
The first problem is you and I. We are not RF experts, right? But anyway,
Nope.
let's assume we must choose an antenna for a device. Then you would feel like a kid in an M&M store in London. Plenty of M&Ms, all kind of colors,
Yeah.
but you don't know what to choose. If you go to DigiKey, you will see there are more than 200 suppliers and 10,000 products. So if you want to do something as an engineer, the first problem that you hit is choice. And of course, you cannot download 10,000 product sheets and compare. Even if you ask ChatGPT, find me the best BLE antenna, the answers are going to be long list.
Yeah.
So the risks for the engineer, and I think that's a problem for the industry, the risks for the engineer are horrendous of picking the wrong product and then building a prototype, etc. So that is one. Now, once you have chosen your product, then the complexity hits because you need to tune that. Every antenna detunes. It's not special to ours or others, and you need to retune it. And I think that's where the industry also has to improve because the retuning is a mathematical thing. It's not. It's something we can calculate. And in order to do that, you don't want to be depending on fees from suppliers. You want to understand yourself and play with it. And for that, we have developed our antenna intelligence platform, basically giving the people, the engineers, the tools to do that tuning themselves. And if the board changes a little bit, the casing changes, there's a battery involved, of course the RF changes. But then we tell them exactly what to do, give them the manual saying, follow our instructions. And it's like a Lego box. You open the Lego box, you follow the manual. If you do that right, then at the end, your model will look what it shows on the box, right? So of course, there are simple Lego boxes for 4-year-olds, and there are complex Lego boxes for 25-year-olds, right? But anything in between. So I think the industry needs to come to a let's say a higher level of abstraction, giving the tools to engineers to enable to play with something which is relatively complex, RF.
So back to the previous question slightly. How does one tune one of these to fit your circuit? Is it a case of design on the other circuitry around? Is there simulation involved? Because as systems get complex and have batteries in the way and stuff like that, I'm sure some simulations or some preliminary designs don't quite fit the bill. So how does one design in one of these antennas?
Yeah. So with any chip antenna, and so with ours, you typically have a so-called matching network, which is a certain topology of it's in your PCB, and then within the matching network, you put 1, 2, 3, 4, 5 passives. You put passive conductors, and there are I don't know, thousands or tens of thousands of elements that you can put. So you need some software to tell you this is how you match it. Traditionally, I agree that was all done with some kind of simulation. And then sometimes also experience, because some of the girls and the guys upstairs here know what they need to do, and a lot of people out there, RF experts, they know what they need to do.
Yeah.
But what we have built is an AI and ML powered model. Basically, we took all the data from whatever we have done in the past, put that into a model, and took all those devices that were really built. So you had the photo from this is what we recommend, and you had the end result, which has been certified by the operator. And we trained the algorithms. So today, and that's exactly what is going to come out at Embedded, you can get your design recommendations for the matching network topology and the passives in seconds. Depending on your internet speed, 3 seconds, 5 seconds, 7 seconds, but it's bam, it's there. And that's disruptive and powerful because engineers get instant support.
Yeah. So just wondering, how long has Ignion been around?
2015 is when we were spun out of our parent company. Yeah.
Oh yeah, I think I remember that from the previous interview. So this new tool, was that just enabled by the recent advances in AI, or has this been something that you've kind of had on the cards for a long time and then finally have managed to release?
So when I joined 3.5 years ago, the first steps were already made.
Okay.
It was called Wireless Fast Track, so the brand has changed, but at the end the concept was the same: make things easier for the design engineer. That's the whole game. And if you want to make things easy, I don't know if you've run simulation software, but you sit there for hours
Yeah.
and days, and
Old
it takes time.
console guy.
Yeah. Exactly there. Well, then you know.
Yeah.
So why not use? And of course, AI came in
Yeah.
2 years ago, 3 years ago, something like that, right? So it helped us to solve this problem. Initially, when we defined the problem, we didn't know about AI itself. It was just,
No.
let's collect all the data, and then we'll find ways to deal with it. And yes, today everybody knows ChatGPT, but that wasn't the case 5 years ago.
Yeah. So I guess that's a pretty rounded discussion of Ignion's technology. But if you were to summarize the key benefits of the virtual antenna in 3 points, what would you say to an engineer who approached you?
Well, I like Tina Turner. I keep it simple. It's simply the
Nice.
simply the best solution. It's not because the others are not good, but if your device, let's say, changes during the design cycle, which is true for any design, then you need adaptability in the antenna performance. And if you choose a predefined tire size, it's only going to fit so many cars. And that's exactly the benefit of this technology. I don't know if you're aware, but we're growing extremely fast, and the response in the market is extremely good. It's not because
I have noticed seeing your antennas on various dev boards, just as I walk around shows. I was like, I can see the little red line.
Well, but imagine you have been trained, if you are using certain tools and similar, then if you have been trained in a certain way, it takes a bit of time to adapt to that reality. Because 3 years ago, we all used Google, and that was the big search engine. Today, everybody, including my kids, use ChatGPT because it gives a better way of doing things. That's exactly how you should think about virtual antenna technology. There's nothing wrong with the old technology. People can still use it. But this is a new wave, and if you adapt to it, I can tell you, 9 out of 10 customers come back or stay forever. We have a lot of repeat business.
Excellent. So if you were looking to try and get some traditional RF engineers starting to use that technology, do you have some evaluation boards that allow them to easily test the performance of these devices? How does that process work?
Absolutely. On most of the websites where you can buy stuff, you will find the eval kits, depending on your radio and the product that you like. And people can always reach out to our inside sales here or get samples, because this is real stuff. This is not software. You need to touch it and you need to feel it. So sure, there is all this support, and most of the radio makers, whether it's for LoRa or for cellular, they have good reference designs with our technology on board.
Oh, good.
Say start from that point of view, because at least you're a good end into the right direction.
Excellent. Well, thank you so much for talking to us today, Jaap. I look forward to that sample book arriving, and I can have a flick through, because that's going to be fun. I really appreciate that when you guys are at shows that you give out these little packets, just so that people can see. I chose one that was big enough that I wouldn't lose it, because I know that tiny one really is scarily small. But hey, I think what would be great to do is to catch up at Embedded World. Are you're in attendance?
Yeah.
At Embedded World?
Okay. Absolutely. So please, invite you and everybody to come by. There will be other nice gifts like what you were just showing. So it's always nice to check out. And I think we have not touched on two subjects because the embedded forest will be about platform and people can see that.
Yeah.
But still, we need to solve something in the tuning domain. I think that's still too complex. You reference
Okay.
that. How do you do that? Well, it's still too
Yeah.
complex. So that is a nice subject. And I think I reached out because of a post that you guys did on energy harvesting. That's going to be a very
Yes.
interesting domain
Yeah.
for antennas also, because there's going to be RF energy harvesting, yes or yes,
Yeah.
for sure.
Cool. Well, I think that is the perfect subject for a follow-up interview. So I'll leave you to your day and your embedded world preparation. And thank you so much for joining us. And to everyone watching, I hope you enjoyed this chat with Jaap Groot from Ignion. And we've done a technical write-up previously, so you can check out the range of Ignion products on the ipXchange website. And yeah, check them out in embedded world as well, because there'll be some nice announcements. Keep designing. Thank you.
Thank you very much, Eamon. Take care.
Hey, yo, where my engineers at?